All right, so we've been looking at a lot of different problems that involve or can be solved with recursion, and this is the last one we'll look at for a little while. So exercise 15 is about checking for a palindrome. So a palindrome is a string that reads the same backwards and forwards. And just like all the rest of the recursion problems that we've done, it's not that it can only be solved recursively, but it's pretty easy to solve recursively, and it's a little bit more tricky, not too bad, to do iteratively with a regular loop. This is one case where recursion probably is gonna be a very is relatively efficient, and the reason it's relatively efficient is because in all likelihood, to check if a string is a palindrome, the string is not going to be that long. I mean, you can imagine a string maybe of 1,000 characters or so, but realistically, you're probably not going to be checking for a palindrome on something that's really all that big. And generally, recursion, as long as the input doesn't get real big, even if it's not the type of algorithm that sort of cuts the problem in half every time or something like that, even if it's just sort of an incremental approach, it'll still be sufficient. So the result that we get will be perfectly fine with recursion, unlike the last example when we looked at Fibonacci numbers, where recursion really kind of fell apart. Okay, so um, let's talk about this recursively. Um, a string is a palindrome if its length is none or one character. Okay, and so that should make intuitive sense, right? If I've got a string A, it reads the same backwards and forwards. If I've got an empty string, of course, it's whether I read that backwards or forwards, it's still an empty string. So that's the simple case. The recursive case is to say, well, a string is a palindrome if the first character is the same as the last character, and all of the interior string, so the second character through the second to last character, is a palindrome, right? So that's the step where we answer the question by asking yet another question. Um, Now, using string slicing, we can actually do that very easily in Python, and I've given one additional wrinkle here where I'd like to ignore the case, right? And so upper and lower case should not affect whether it's a palindrome or not. And also not to consider, we might allow some non-alphabeticals to be in the input. Maybe we'd have the user type things in. I frankly am going to use these test cases first. But the user can type characters in, but any commas, periods, numbers, spaces, tabs, anything like that will not interfere with the palindrome calculation. And the way I'll attack this is by removing all those characters before I consider whether it's a palindrome or not. That said, I'm not going to start with that point, right? I'm just going to assume simple input, all lowercase, no spaces, no punctuation, no numbers, and then I'll gradually just build up and include those type of use cases. Okay, so I'm going to first start off by stubbing out my code. I'm going to have a function called isPalindrome, and that'll take an input string, so string. And for now, I'm just going to return false. I'm also going to write some test cases. So I'll write my test function, right? So test pal and a string and an expected value. And what I'll do here is just say if is palindrome of string not equal to expected, print test string failed, got not expected, expected, expected. A little repetitive, but I guess the job done. Let's remove some of these trailing strings. Else print test string passed. All right, and let's set up a few tests. So test pal, and we'll just do simple ones first. So A should be true, right? Um, in fact, the simplest one is the empty string, right? I mentioned that. That should be true. We can do test pal ABA, right? That's true. We should do a test case with an even number of numbers too. ABBA, that's true. Let's include something that should be false, ABC. Let's include something like that. And that's probably good enough to get us going, and then we'll start adding some more use cases as we go when we deal with numbers and spaces and periods. All right, so when we run this, obviously, I mentioned, I think before, I like to run the tests and make sure that, oops, I think I messed that one up, but I like to run the test and make sure that they actually fail first. So I've got a syntax error over here. Not expected. And that's okay. Oh, I forgot the comma here. Oops, still not. And, oh, okay. Yeah, so this isn't C++ or Java. We'll change that. And false. Oh, okay. I've been programming in another language for a little bit, so making some mistakes. Okay, so we've got test cases fail, the empty string. Of course, the ones that were supposed to return true are failing. Right? And the ones that were supposed to return false are, of course, failing, and that's fine. That's the way it's supposed to be. Okay, so let's think about this recursive algorithm. First of all, we can figure out the base case, right? So if the length of the string is less than or equal to 1, it is definitely a palindrome. Return true. Right? Automatically, I'm going to get some test cases passing now, right? So I'm down to these two that should be returning true, but are returning false. Right? So let's tackle the recursive step. Right? So the string is a palindrome. And remember, the recursive step is that if the first and the last are the same, the string is a palindrome if the interior is a palindrome. So, if we have something like this, A, B, C, B, A, what we're going to do on this first input is check to see whether or not these two are equal. And if they are, then I'm going to call the same function is palindrome just on this interior string. Right? That will get brought in as BCB. We're going to check this and this. And since those are the same, then I'm going to call the recursive call on the interior string. And that, of course, is true because it's of length 1. Okay, so in Python, this is pretty easy to get the last index, first and last index. So we'll say return, I'll get rid of this false. We will return the answer of is string 0 equal to string -1. Remember, that's indexing from the end, and is palindrome of the string 1 to -1. And remember, that is exclusive, so basically we're getting the inclusive, the second element in the string, the second character in the string, and up to but not including the last element in the string. All right, so let's give this a run. Okay, so all of our test cases are passing. All right, so now let's build in more. I actually had some test cases here, so let's use those. Test palindrome radar should be true. Right now, the way I have it, it's going to be false because this is not equal to this. I've got two more test cases. No lemon, no melon, with a period at the end, should be true. And 1, 2, 3, 4 should be true too, because that's really an empty string. It has no character data in it. If we run the tests, of course, we're failing. All right, so our task here is to sort of get rid of or strip all of the sort of anomalies from these strings. I'll focus in on this one first, right? I want to convert everything to lowercase. So the first thing I can do is say string equals string to lower. And actually, I probably shouldn't use that string. Let me change that because that's a little confusing. It's okay the way this is right now, but my syntax highlighting is starting to think that string is actually a function, which it is, of course. So let me call it s instead. I don't want to continue that. Okay, so I can call to lower. Sorry, lower. And you can see radar now passed. That's not quite the right thing to do here though, because remember, is palindrome is being called many, many times, right? So I'm actually calling lower on, the first time I call this, it'll convert radar to all lowercase, but then every single time I call this function, it's going to continue to make it lowercase. It's already lowercase. So I'm going to rearrange this thing because I'm going to have some more initialization too, sort of a first step to clean the input. And I'm going to break this into two functions instead. I'll write an actually I'll make it an internal function. Def is pal string. And instead of instead of actually doing the recursion in this primary isPal function, I'm going to take this out and I'm going to put this in the internal function. And I'm going to make sure I got to make sure I change this name of this function. And then inside isPalindrome, instead of I'm going to clean the input first and then just return isPal, right, on s. Okay, so notice what I've done here. The calling code, right, and in this case it's this testpal. The calling code is actually going to call the full isPalindrome function. IsPalindrome is not recursive though. It does things in two steps. At first it cleans the input, and then it calls isPal, which now kicks off that recursive process. I should rerun this, make sure that nothing went wrong. Okay, it's good, it's passing. All right, next, I need to deal with spaces, all right, punctuation and numbers. So basically the idea is that no value, no character should be considered if it's not an alphabetical character. And again, we can rely on some of the features of Python to help us with this. So I'm going to write another function. And so let's just call it 2 characters, and it'll take a string. And in fact, this is my clean. In fact, let's call it clean. Clean input, right? Takes s. So I'm gonna do it this way. It's gonna convert everything to lowercase first, just like we did before. And now it's going to build a new string. Let's call it letters. It's gonna start empty. And it's gonna go through every letter in S and see whether it's alphabetical. So for C in S, if it's alphabetical, and how will we do that? Well, we can say if C is in, a pretty long substring here, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Hopefully I didn't miss any there. This is a full string, and I'm seeing whether or not C is a substring of it, right? C is a single character. If it's 1, if it's a punctuation, if it's anything like that, it doesn't get in there. Okay, so if it is, I'm going to do letters equals letters plus C. And if it isn't, I'll just ignore it. And at the end, I'll return letters. All right, so I want to point out the importance of keeping the non-recursive stuff separate from the recursive stuff. I could call clean input inside is pal and just have is pal, but then I would be constantly doing this, and it's a waste of time. It's a waste of resources. Right, so let's run this and see how we got. See what we got. Test no lemon. Yep, it worked. Passed. Passed. And it looks like we're all set. All right, and we can change this function now that we've got. You want to almost think about these test cases as sort of scaffolding. Once you've got your function that you've exercised, you've tested all the different possibilities. Well, now if you want to convert this so the user can type in the string instead and we just get rid of all this, that's fine. You can do that. And I'll post the solution that I finally post. I'll just leave that as the user typing in. A lot of times test code will stay though. A lot of times it'll be useful to keep the test code somewhere in the program, even if, if you want to keep things really, kind of simple, you could even comment it out. But it's useful to keep your tests around because eventually you're going to probably change stuff. This is probably not going to change, but most times you write programs for people, the requirements or the rules do change eventually.